least common multiple. And students always get this confused with greatest common factor. But hopefully I'm going to teach you something today that will help you remember that, okay? Because they're two different things. We work them kind of similar, but they're different. Again, this is good everyday stuff. For instance, our everyday situation over there before we find out how to do it. Two commuter trains leave the station at the same time. The blue train returns to the station every 3 hours. The red train returns every 4 hours. When will they be at the station at the same time again? Okay? That's the type of problem. Do you see how that's different from last week when we did greatest common factor? And what was our story?
Like goodie bags.
Goodie bags. I had a bag of 48 and I had a bag of something else, and I was trying to put them in the bag and have the same amount. This is later on in time. I got one train coming back to the station every 3 hours. Another train that left at the same time comes back in 4 hours. And then he leaves, and then they leave. At some point in the future, they're both going to get back to the station at the same time. That is least common multiple. Okay? So now let's come up here and break down again what we were talking about. Now let's see how different this is. We're comparing it to greatest common factor. This is least common multiple. So, let's start off. Least.
Small. Not as much. Smallest.
Smallest.
Not as much. Smallest.
Not as much. All blue.
Less than.
Not as big. Not as big.
Smaller, but not much big.
Smallest. Now already this is different than greatest common factor. Do you agree? Already it's different. Because greatest common factor starts off with the word greatest, biggest. This one starts off with smallest. Hogan, you with me on that? You kind of gone there with Peter Pan for a second. Y'all both after Tiger Lily, I know. Pretty little Indian girl, I agree, but stay here in math, okay? There you go, buddy. Stay with me. Peter Pan, go home. All right. Smallest. Common.
Most frequent.
Not most frequent. Same. What else did we put last week?
Alike.
Alike. Now that is the same as last week's greatest common factor, because we're looking for numbers that are the same in both instances. One of them is the biggest, another one is the smallest. Now let's go down to the third word. Multiple. Multiple. A multiple is a number that is made due to the fact that we multiplied. A number made by multiplying. We could go further. Times the counting numbers. Times the counting numbers. That's specifically what we're multiplying. A number times the counting numbers. Now, folks, how is that different than greatest common factor? Well, Justin, what was factoring?
A lot of the same numbers, like
Like if
Mathematically though, Justin, I mean, you're doing great, but mathematically, what were we doing when we factored? Let's ask Travis.
Make a list of factors using.
No, I want to know what factor means.
Oh, a number that will divide into something.
Division. Ding, 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 ding in your brain right now. Ding, ding, ding in your brain right now. Multiples is using multiplying. Factoring, we did dividing when we made our list, right? We said, what will divide into this number? And we started listing 1 and 2 and 3 wouldn't. 4 and didn't we? We were dividing with factoring. Today, we're not going to be dividing. We're going to be multiplying. Now, how can students every year get these two flip-flopped? They do it because they do not learn the difference between factoring and multiplying. Factor means you divided. Multiple means you're going to be
Multiply.
Oh yeah, that's what the word means. It looks like multiplying. Don't get them flip-flopped. Factoring, you do dividing. Multiples, you're doing multiplying. For instance, here we go. The multiples of 6. Now, if I was going to do the factors of 6, I would go, what divides into 6? And you go 1 and 6. 2 and 3. 3. Oh, we already have it. Our list is done. Remember that? That was last week. We're not doing factors. We're doing multiples, meaning we multiply 6 times 1. 6. 6 times 2. 6 times 3. 6 times 4. Next one. 30. 36. 42. Blah, 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 blah. Right? Notice my list could keep going on. Forever, right? Because we're multiplying. In multiples, the list goes on. In factoring, our list ended. In multiples, my number I start with keeps getting bigger. In factoring, my list was numbers that were littler than 6 and stopped at 6, right? So how do students get them flip-flopped? I don't know. It just amazes me. But you're going to be the first bunch that doesn't get it flip-flopped, right? Bullcorn. Somebody in here is going to flip-flop them. It happens every year because they go off with Peter Pan and don't concentrate. Don't be looking at Logan. Some of y'all others did too. Sometimes. So, here's our multiples like that. Okay? Alright. So, if I'm going to find the least common multiple between two numbers, just like greatest common factor between two numbers. And in a minute, we're going to go to our story problem, and we've got to find out when 3 and 4 in the future become the same number. Common. Right? That's what we're doing. Find the least common multiple. Somewhere in the future, when I make a list of 6 and a list of 9, they're going to be the same. Somewhere in the future. That's what I'm looking for. The first time that they get there. Okay, so how do we do this? Well, last week what did we do with factoring, or greatest common factor?
Teacher.
make a
Sideways. Sideways teacher.
horizontal sideways T-chart. I don't like them up and down because it wastes a lot of paper. Let's go sideways and save paper. Make a T-chart of multiples of the numbers. So I'm going to do this first example as I write my notes on how to. And there's only 2 how-tos, isn't there?
Yes.
Well, that's pretty nice. So this ought to be pretty easy, eh? Oi. 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 Now, we already done 6. What are the multiples of 6? 6, 12, 18, 24, 30, 36. Now, since my list goes on forever, I need to stop sometime and do the other one to see if I found it. Because I'm going to be looking for, find the first number that is in both lists. We're looking for the first number because we want the least, the smallest. Those 2 trains are going to come around and be at the station at the same time sometime in future. Then as they keep going, they're going to repeat and come to the station at the same time again later than that one. And then another one. There will be several commons. But we want the leastest one, the smallest. The smallest. Alright, let's do 9. What are the multiples of 9? 9 times 1. 9. 9 times 2. 9 times 3. 27. 9 times 4. 36. 9 times 5. Blah, blah, blah. Now, I went further, and in a little while we're going to learn not to go further. You with me, girlfriend? Got your chart? Go ahead. Got to let her get caught up. Do you see some common numbers in both lists?
Yes.
I see 18, 36, and if I kept going with 6s and kept going with 9s, I bet I'd have some more circled out here. What do y'all think?
Yes.
Okay. Find the first number that's in both lists. What was the first one we circled?
18.
So the least common multiple is 18 for 6 and 9. Not the 36. I wanted the first one I came to. So the next time I do it, I'm just going to stop once I get the first one. I'm not going to go see if there's some more. Because I'm not in the campfire. I don't want s'mores. I want the first one. And then I'm stopping and going on. All right, baritone? All right. So, was that one very hard? No. Well, let's find the LCM of 15 and 12. Okay? The factors of 15.
15.
Bull corn, y'all let me say the wrong thing. I tested you. I said the factors of 15.
Multiple.
No, we're not factoring, we're multiples. Listen, y'all. In my class, you better listen, because I'm going to throw stuff at you. Verbally and physically. You see here, we're not factoring today. We're not factoring today. We're multiplying today. We're multiplying today. All right. What's 15 times 1?
15.
15 times 2.
30.
15 times 3.
45.
15 times 4.
60.
15 times 5.
75.
15 times 6. 90. I hope that's enough. I'm going to stop and see if that's enough, y'all.
I ran out of room.
What?
I ran out of room.
Well, that's your fault for not starting far enough to the right, left, whatever. Okay. Now let's do 12. And once we get one that's already in the list over here, we're stopping. We're not going on, okay? 12 times 1. 12 times 2. 12 times 3. Next one. 48. 60. Ding, 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 ding. Why did we stop? I found one. The very first one that's in both lists is 60. So the least common multiple is the number 60. Everybody with me on that? What y'all think?
Pretty easy.
Pretty easy. Now what did I do on this last one to try to jack with your head? 3 numbers. Can we find the LCM of 3 numbers?
Yes.
Yeah? Instead of both, it's all lists. Right? If they do 3 numbers, then we got to do 3 T-charts, or 3 in the T-chart, and then find the first one that's in all 3 lists. So I got a 4, 8, and 10. All right. Let's do the multiples of 4. 4 times 1. 4, 8, 12. Have y'all noticed that it's really just counting by whatever that number is? But please don't forget the fact that it is multiplying times the counting numbers. That's what makes it different than factoring, because we're multiplying. All right, 12, 16, 20, 24, 28, 32. Maybe we got it. Here we go. 8. 8 times 2, 16. 8 times 3, 24. Oh! 24. Maybe I got one. 10 times 1. 10. 10 times 2. 10 times 3. Why did I? I had 24, 24, but there's no 24 in this one, so I got to keep all my lists going, don't I? Right? Right, so let's keep going. 32, 36, 40, and what's another one? 44. Maybe we went enough. Here we go. 8 times, we were at 8 times 3 is 24. 8 times 4. 32. Oh, I got 32 and 32. 10 times 4. Oh, poop. I gotta keep going now. 8 times 5.
40. Got it. We're good.
Are we good?
Yep.
Ding, 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 right? Bam. Here, look at here. 40, 40, and 40. The first one that's in all 3. So LCM 40. So really, did that curveball trick you?
No.
You knocked it out of the park, didn't you?
Yep.
Just like Adrian Beltre. Boston kind of falling on tough times there, Ty Watson, aren't they? They've lost how many out of 19? Something bad. 12 out of 19 or something in the last 19 games. Boys, are you switching over to the Rangers now? You're not going to switch over? Hey, if it's the Rangers in Boston, you and me going to have a bet. You got it? All right. You just tell your mom we're going to have a bet. How close are you? You pretty close? Or you need to come over here by Logan?
Maybe come over there.
You okay? No? Okay, don't jiggle it. Try not to jiggle. All right, here we go. Now let's do our story. Yeah, right there's good, right there. All right. Be sure you zoomed in. Our 2 commuter trains leave the station at the same time. One of them has a longer route. And the shorter one gets there back before the long one. And he's left again before this one gets back. But sometime in time, in the future, they're going to get back at the same time. That's the LCM. what is the first time they get back. So what's our two numbers? 3 and 4. Okay? So what are the multiples of 3? 3. And the next time it comes back to the station, it will be 6 hours. 9 hours.
12. Oh, sorry.
You better not be way ahead.
9, 12, 15, 18, 20.
I'm 9, y'all. Stay with me. 12 hours. 15 hours. All right, let's go to the 4, the train that makes it every 4 hours. 4 hours later, he'll be back. 8 hours later, he'll be back. 12 hours later.
No way.
All right, so the two trains will be back at the station at the same time after 12 hours. So, I could put LCM as 12, or my answer really is they will be back. When will they be at the station at the same time again? 12 hours later. Okay? Now, y'all, we're not going to see any questions like this, but I'm having a very strong feeling about this new STAR test that's coming out by the state of Texas instead of the tax test. And they're saying it's going to be deeper. I'm thinking that this question right here in STAR test terms will ask us, how many times has each train gone around before they're back at the station at the same time? 1, 2, 3, 4 times around, where this one went 3 times around. So I'd have to say the 3 hour is the blue. I would say blue was 4 times and the red was 3 times.
On the answers, would they put it?
They would put answers blue and red this, blue and red this, blue and red this, blue and red this. I'm just guessing. They have not told us what the test is like, but because they said the questions will be more multi-step and deeper questions, you would have to be able to find LCM and then count up and understand what the question's asking, that they want to know how many times this first train had to go around before they got back at the same time, how many times this one. So the first one was 4 times around, the second one 3 times around. So we got to be ready for that. Kill it, girlfriend.